An important part of any machining process is the cutting tool, which removes the unwanted material from the blank as chips. In conventional machining processes, the tool material is always harder than the workpiece material. Let's have a look at the parts of a cutting tool with reference to lathe. This part is the shank, which is held at the tool post. This face is the rake face, over which the chip flows. This is the principal cutting edge, which does the cutting job. This one is the auxiliary cutting edge. This face is called principal flank and this one is the auxiliary flank. This point is called tool point or nose, where the two flanks and the rake face meet. This portion is called the heel. Geometry of a tool is defined by a set of 7 parameters called tool designation or tool nomenclature. There are various systems of tool designation, the most popular ones being ORS and ASS. The orthogonal rake system is based on 3 mutually perpendicular planes meeting at the tool point. The horizontal plane is called reference plane pi r. The vertical plane containing the primary cutting edge is called cutting plane pi c, and the orthogonal plane pi o is the plane perpendicular to both pi r and pi c. Now, if we look normal to the cutting plane, then the planes pi r and pi o form horizontal and vertical lines. This angle is called inclination angle, while this one is called auxiliary clearance angle. Similarly, if we look normal to the orthogonal plane, the planes pi r and pi c become horizontal and vertical. Now this angle is orthogonal rake angle or just rake angle. This is the principal clearance angle. In a machining process, the angle between the PCE and the direction of longitudinal feed is called the principal approach angle, whereas the angle between the auxiliary cutting edge and the feed is called the auxiliary approach angle. Most tools also have a nose radius instead of a sharp edge. These 6 angles and the nose radius in a specific order gives the tool geometry in orthogonal rake system.